The next problem will still be about resolving in equilibrium. However, this time it will be at other angles. So let's have the problem. So the problem says a block of mass 10 kilograms is held in equilibrium on a slope at an angle of 20 degrees to the horizontal by a force F acting at 15 degrees above the slope. Find F and the normal contact force. So our problem is to find the F and also the normal contact force. So first and foremost, what we're going to do is that we need to draw the diagram of the given problem so that we will be having a perspective on how to answer the given problem. So let's start. Again, the problem says a block of mass 10 kg is held in equilibrium on a slope at an angle of 20 degrees to the horizontal. So since it says that it is already equilibrium on a slope with an angle of 20 degrees to the horizontal, we can present our problem like this. So there will be a horizontal. There will be a horizontal. And then there is a slope. The angle is 20 degrees. So approximately it will be here. So this is our angle here, 20 degrees. Okay. That's 20 degrees. So therefore, we can just extend it a little bit. So let's draw the given block of mass, which is 10 kilograms. So it's here. So this is 10. So automatically, if that is 10 kilograms, if the mass is 10 kilograms, we can say that there will be a force here going downwards. That is your 10 Newton. Okay, we can just write here 10 Okay, that is your 10 Newton. Or if you want to write directly, remember that in mechanics, the G is equal to 10. So we can just write also. So if you want to write 100, it can be. It's okay to write 100 Newton for that one. Now, so if we have your weight, which is 10G, also going upwards, we will have here your R. So the R is your normal contact force. So that is one of the problems. We're going to solve it later. Now, let's continue. Okay, let's continue. So to be able to answer it later easily, what we're going to do is we're going to extend first this triangle here. So from here, we can draw a triangle. Extend. So this will be our right angle here, 90 degrees. So this triangle is the equivalence of this triangle here, so that you can see the parallel and the perpendicular. Okay, so you can see the parallel and the perpendicular. So we can say that with this triangle, the 20 degrees will be here. Okay, your 20 degrees will be here. Okay, and since we've learned with what we learned in the previous concept, the components are the one forming the right angle. Okay, so the components are the one forming the right angles. So therefore, we can say, so if you're 20, okay, let's try to make it outside so it's bigger. So your 20 degrees will be here. That is 20 degrees. Okay, so you can see it clearly. Now, so therefore, this side here will be, remember that this is the opposite. This side is the opposite of the given angle. So we can say that that will be your f sine theta. Okay, that will be your f sine theta. So if that's your f sine theta, we can say that that will be equal to 100 sine 20. Okay, that's the 100 sine 20. On the other hand, the side here, this one will be your 100 cosine 20. Okay, that will be 100 cosine 20. Now, let's continue the diagram. So it says that there's a force F acting 15 degrees above the slope. So it is 15 degrees above the slope. Now, so with this, we can say that since it says that it is 15 degrees above the slope, so from the block, there is another force going in this direction. Okay, and of course, it is with 15-degree angle. So we can assume that this is horizontal. This is parallel to the slope. Well, okay. So there is an angle here. This is 15 degrees. Okay, that's a 15-degree angle. Okay, so this is your force. So this is the F here. Okay, that's the F. So if that is your 15-degree angle, so we can just draw again, form or construct a right triangle. Okay, construct a right triangle. Okay, so this side, I'll make it use blue one. So this side will be your F sine. This will be your, wait. This will be your F sine 15. Okay, that will be your F sine 15, that side. And the one at the bottom will be your F cos 15. Because remember, the sine is the one that is opposite the given angle. Okay, so let's continue. So this time, let's try to resolve in parallel and perpendicular. Okay, parallel and perpendicular. Now, let's start to resolve in the parallel. Okay, so when we say parallel, we will be looking on the forces that is parallel so that we will be able to find the F, find the force. Okay, let's resolve in parallel. Okay, parallel. Now, let's start. Let's continue. Now, what are the forces here that is parallel? So we can see here, one, parallel, we have your F cos 15. Okay, so we have your F cos 15. By the way, we need to be careful with the directions. Okay, so take note that the force, the direction is going there. And of course, if that is going that way, this one will be going to the right and this one will be going upwards. Same thing with this one. Since the weight is going down, so therefore this will be going that way and this will be going this way. So remember that the force is considered as a vector quantity. So we will be considering the components as well. Now, so what are the parallel forces? So what we have here, first, since there is no acceleration here, remember that the law that we are using is still F is equal to ma. So since there is no acceleration, we can just equate the right side to 0. Now let's continue. So this will be equal to f cos 15. Okay, that is one. That will be f cos 15. That is going to the right. And then what else? The other one will be minus, that is your 100 sine 20. Okay, let us show 100 sine 20. So equal to 0. Why equal to 0? Because there is no acceleration. So if you multiply the mass by 0, that will be 0. So this is your force, the component that is going to the left, and this is the one that is going to the right side. So let's try to solve. So therefore, this becomes f cos 15 equal to 100 sine 20. Okay, f cos 15 degrees is equal to 100 sine 20. Now, if we're going to solve for f, so this becomes f will be equal to 100 sine 20 all over cosine 15. Now, let's use your calculator, and don't forget to express the mode in terms of degrees. So 100 sine 20 divided by cosine 15. So our answer is approximately, so let's just express it into decimal place for the force. So F will be equal to 35.41 Newton. Okay, so the force is, or the F is equal to 35.41 Newton. Okay, so we're done. So we're done resolving in the parallel. Now, let's continue. Let's resolve in perpendicular. Let's resolve in perpendicular. Perpendicular. So when we will be resolving in perpendicular, so the same process, we're going to look for the components which are in perpendicular to the given slope. So here, the one that is in perpendicular is this component. This is going upwards. And then the other one, this one, this is perpendicular also. And the last, we're going to consider the R. Okay, we're going to consider the R because that is one of the problem. This is the other problem, the normal contact force. Now look at the direction. The R is going upward. Same thing with the component here. And the other one is going on the opposite direction. So therefore, with this, we can say that that will be R plus F sine 15 degrees minus, so that is 10g cosine 20, or we can just write it 100 cosine 20 is equal to 0. So that is our statement. So again, we are still using F is equal to ma. But since there is no acceleration given in this problem, so that's why we can just put the right side equal to 0 or express it in terms of 0. Now let's continue. Let's try to solve. So solving this, we're going to have R will be equal to 100 cosine 20 minus F sine 15 degrees. So we already know that the value of F is equal to 35.41. So we can just put it 35.41 sine 15. Okay, 35.41 sine 15. Let's just use parentheses so to avoid confusion. Okay, so 35.41 sine 15. So let's use your calculator. So that will be 100 cosine 20 minus 35.41 sine 15 degrees. So the result will be equal to 84.18 Newton. So again, let's just express in 2 decimal place. Okay, so we can write it as R is equal to 84.80. It's 80, 81, 84.80 Newton. That's the value of your R. Okay, so that's the solution of this problem. So the thing that you need to remember is you must first draw the diagram. Okay, draw the diagram.